Alright, so this is the problem 62 from your reference book, Resnick Halliday Walker, 10th edition. In this problem, we are going to find out that net force on particle 4 due to other charges. So in this figure, if you closely observe, this is actually the charge particle 4. I have to find out the net force over there due to other charge. So this is charge 2, this is charge 3, and this is actually the charge 1. This is actually the charge 1. Fine. So first of all, I'm going to they give me this information, actually Q1, actually I'm going to write, say this is that the given information. Q1 is plus 3.2 into 10 to the power minus 19 coulomb, and Q2 is negative, which is minus 3.2 into 10 to the minus 19 coulomb. Q3 is positive, which is double of that Q1, 6.4 into 10 to the minus 19 coulomb, and the Q4 is also plus 3.2 into 10 to the minus 19 coulomb. They also give some information, which is theta is 35 degree, D1 is 3 centimeter, and D2 equal D3 actually the 2 centimeter. Just given into the question. Fine. So first of all, I'm going to draw that free body diagram. So the forces acting on that this charge particle 4. Since there are 3 charge particle 1, 3, and 2, going to create the force on that charge particle 4. So I'm going to draw that free body diagram first. Say this is to be, say that this is the force. I should write, so this is the force on 4 due to 2, right? So I'll write down this is the F24, which is the force on, fine. Since your Q4 is positive and the Q2 is negative, this Q2 will attract Q4 towards itself. So that's why F24 will be towards the positive Y direction. Now the Q3 is positive, which is 6.4, and Q4 is also the positive. So that means they will repel each other. So that's why this is to be that force. Should write, so this is the force on 4 provided by the 3, right? This is the force. Now what about this Q1 is also going to be the repel the Q4, because both Q1 and the Q4 is positive. So in that case, the direction of this force would be toward that direction. So this is actually that force on 4 provided by the 1. So these are the forces reacting on that 1. Fine. Now I'm going to find out the magnitude of these forces. First, say that F24. How I can write down this F24? So this is that force F24. So this is to be that K, Q2, Q4 divided by the distance between these two charges, actually that D2 square, and the direction of this 4 would be towards the positive Y direction. So that's why I'll write down this is actually that J hat. Fine. Now if I plug in the value of this parameter, what I will find, this is a be K, actually the 9 into 10 to the power 9. Q2 is 3.2 into 10 to the minus 19 coulomb, and Q4 is also 3.2 into 10 to the minus 19 coulomb. So I drop the coulomb over here. It may be necessary to write down that C. Divided by D2 square. D2 is basically the 2 centimeters. So I should convert that into the meter. 2 into 10 to the minus 2 whole square into Z hat. So this is my force. Fine, then if you do some algebraic calculation, you will find out that F24 would be 2.304 into 10 to the power minus 24 Newton Z hat. So this is the value of this F24. Fine. What about F34? F34, that should be K Q3 Q4 divided by distance, which is T3, into this F34 will be towards the negative X direction. So that's why I'll write down the minus I hat. So if you plug in the value, which is 9 into 10 to the power 9 into Q3 is 6.4, right? Q3 is 6.4. 6.4 into 10 to the power minus 19, and Q4 is 3.2 into 10 to the power minus 19 divided by D3. D3 again 2 centimeter, 2 into 10 to the minus 2 square into minus, I take this minus sign in front of there, so I hat. So if I do that calculation, I'll find out if 34 would be minus 4.608 into 10 to the power minus 24 Newton I hat. So this is actually that R34. Fine. Now I have to find out F14. F14 I can find out F14, which would be basically that one, right, toward that direction. So the direction of this one I have to find out. That I can say the unit vector will be towards basically that direction, right, vector itself, or you can say this is the unit vector will be the D1 hat. I will use in that form. Say what will be that? This is going to be that K Q1 Q4 divided by D1 square into D1 unit vector. And D1 unit vector we can find out that the vector D divided by magnitude of vector D. Fine. Now what will be the vector D? Look at this. I can find out that vector D basically this one. If I want to find out that one, I can consider this is one component and this is another component, right? Since this is theta 1, I can say this is to be also the theta 1. Then D1 vector, I can write D1 vector over here is to be the D1 cos theta 1 I hat plus D1 sine theta 1 Z hat, right? So this is basically the D1 vector, and magnitude will be also the D1 you can find out. So d1 square cos square theta plus d1 square sin square theta. So cos square theta plus sin square theta basically the 1. So magnitude will be the d1. Fine. Then I can write this is would be k would be, or you can write one more line which would be that k q1 q4 divided by d1 square, and the d1 head would be basically that d1 vector divided by d magnitude, right? Then I will find out this will be the k q1 q4 divided by d1 square into, this would be basically that cos theta 1 I head plus sin theta 1 z head. This you can factor out the d1 over there, and this d1 will be there, cancel out. So that's why this is would be that formula. Now I'm going to plug in the value because I know that everything over here. So this is would be that f14 in that case is a 9 into 10 to the power 9. Q1 is 3.2 into 10 to the power minus 19 into Q4, which is also 3.2 into 10 to the power minus 19 divided by d1 square. d1 actually the 3 centimeter, 3 into 10 to the power minus 19, sorry, 10 to the power minus 2 square into cos 35, because theta 1 actually 35 I head plus sin 35 z head. Now if you solve this one, you will find out that the value of this f14 will be 8.386 into 10 to the minus 25 I head plus 5.867 into 10 to the power minus 25 z head. So this is actually that f14, force on particle 4 due to the particle just particle 1. Now I have to find out the resultant of these forces, right? So because these three forces I'm going to add vectorically algebraic summation of that. So then I can write this is to be f net. I should write sum of these f14 plus f24 plus f34. Now if you add them together, if you add, you will find out that this is going to be the minus 3.76 into 10 to the power minus 24 I head plus 2.89 into 10 to the power minus 24 z head. So this is actually that force on that one. Now I can find out the magnitude of this case, right? So this is actually that, or you can write the net force. The magnitude would be basically square root of that thing. What would be that? That case, I should write 3.76 into 10 to the minus 24 square plus 2.89 into 10 to the minus 24 square root. I'll find out the magnitude of these forces will be 4.74 into 10 to the minus 24 Newton. This is that magnitude answer. And the direction, what would be that? Look at this. This is the component of this vector is basically x component is negative. So that means I should write this. This will be my x component of this force, resultant force, and the y component is positive. Then the resultant vector will be over here, right? So fine. If I find out that angle from there using that formula, this will be your angle over here, right? That's going to give you the angle theta. Fine, I'm going to find out that angle. Now the theta, then you can find out theta would be tan inverse, right, y by x. So 2.89 divided minus 3.76, right? If you use, you'll find out that minus 2.89 divided by 3.76, because 10 to the minus 24 water will be cancel out. So shift tan inverse, that's going to give you that minus 37. So angle is going to be basically, so minus 37 basically is going to be the clockwise. So this is to be minus 37.54 degree from negative x-axis, or you can write 180 degree plus minus 330. So because we count down the angle 142.45 degree from, and this is clockwise, CW, 142 from positive x-axis counterclockwise. So that means this 142 basically that angle. So this will be your answer of this question. Okay, thank you very much.